G'day, I've got a new toy. It's an Alinco DR-735. It's a 270 FM twin bander. Now, like a lot of modern radios these days, it's much easier to program all the memories and set up the configuration to your liking using PC software. And to do that, you're going to need some sort of programming cable. I wasn't prepared to spend the 69 bucks on the Alinco cable, so I went searching on the internet to see what was out there and came across this. This is by N0DIM. As you can see, it's a while ago. It's December 2014. It looks pretty simple. It uses an FTDI USB serial adapter. You've got a 10K resistor there as a pull-up and a single 1N4148 diode, which merges the TX and RX lines together. And that's similar to the ICOM CIV interface, which just uses two wires. I built this thing up. It's pretty easy. I soldered the resistor and the diode directly to a female header socket, and I'm using a header socket because I want to be able to use the FTDI adapter in the breadboards. Hooked it all up, and the bloody thing does not work. Now, I don't know what Alinco transceiver this guy was using, but it certainly does not work with a DR-735. Now, to try and understand why, and it did occur to me that shit, this is a brand new radio out of the box and it could be faulty, but you know, you hope not. Now, to understand why it wasn't working, I was referring to the schematic of the radio. And isn't it nice when we get these? You have a chance of fixing any faults should they occur. So let's have a look at that. The programming line is referred to as clone on this schematic. It uses one of the pins on a stereo external speaker connector. It comes through this 1K resistor. We have two protection diodes here. This is a Schottky diode to prevent the signal line from going beneath -0.2 of a volt. And we've got a 5.1 volt Zener here. So these two diodes effectively protect the input of the microcontroller. That signal line also gets pulled up to +5. This is the +5 volt rail via a 10K resistor. And that's part of the problem, because on our programming lead we have a 10K resistor, and both these resistors are effectively in parallel. So that's a 5K pull-up. And the 1N4148 diode isn't the best choice because a silicon diode normally has a forward voltage drop of about 0.6 to 0.7 of a volt. And what's happening when that TX line is driven low, it isn't quite getting low enough for the microcontroller to recognize that as a logic 0. It's the effect of the pull-up and the voltage drop. It's just not quite getting low enough. But not to worry, it's really easy to fix, and that's coming up. So let's take a look at my schematic. As you can see, I've gotten rid of that 10K resistor. We don't need that. And I've changed the 1N4148 diode for a BAT85 Schottky diode. Schottky diodes are much better in this application because they have a forward voltage drop of about 0.2 to 0.3 of a volt. So that, combined with the higher pull-up or the weaker pull-up, means that that TX line is going to get driven closer down to 0 volts for the microcontroller to recognize that as a logic 0. So once again, I've soldered the diode directly to the header socket so I can reuse the FTDI in breadboards and things. You can see the cable is soldered to that as well. And I've encapsulated that in hot melt glue. There isn't really a need to put this in an enclosure or anything. It just seems a bit extravagant and a waste of money. With the 3.5mm stereo connector, the signal line goes to the ring and the ground goes to the sleeve. You'll see here in this picture, I actually cut off the solder tab going to the tip connection just to minimize the chance of any short circuits. Now, this is not going to win any beauty contests, but just as well it's not a beauty contest, hey. And I can just reuse my adapter in the breadboard like that. Let's give this a go. We'll hook it up to the radio, and the programming lead goes to the external speaker port that's closest to the fan. Plug that in like that. Let's take a look at the desktop here, and with Device Manager open, if I plug in my FTDI, we'll see the COM port pop up. There it is, COM8 just popped up. Let's turn the radio on. There we go. Let's open the Alinco software. And to be honest, this software is an absolute piece of shit. It's really clunky, but it does the job. Make sure we've selected our correct COM port, COM8. And if I click on read, you can see the progress indicator flash there. It's read memory channel 0. Now it took me a fair while to work out that it would only read and write to the radio where you have selected on the screen. So for instance, if I highlight memory channel 1 and read, it reads that from the radio. And what you can do, you can actually, this is not meant to be a tutorial on this shit software by the way, but we're here anyway. So if you were to click on channel up there, the top left of that matrix, then click read, it will read the entire contents of the radio. We're not going to do that right now because it will take forever. Now, what I did, I grabbed one of my other radios here. This is an Anytone DMR handheld. So I exported all the analog memories out of that into a Excel spreadsheet, and there, you know, you can massage your data around to suit the new radio. Then you can import it into the 735. So I did that. I've created my file so we can open that. I've got two here, atomcondense.735. We'll open that, and all my memories are there. My preferred VFO ranges, my colors, all the function settings are to my liking. Now, for instance, to send just the function settings to the radio, this page is automatically selected. It selects the whole lot, and we would click on write data. We can see the radio was responding, and at the end of that, and this is going to take a while because I had the memory channels selected at the same time, we will just speed the video up. We're almost there. Just be careful you don't have all your memory channels selected, because it does take about a minute or so to write all of that, because this radio has an abundance of memories. And at the end of the write, the radio does a reset, powers up again with your settings. Yeah, this radio's got like 1,000 common memory channels. It's got 100 for the left side, 100 for the right side, and I think there's 100 or so dual memory channels. So there's a shitload of memory channels there. So as you can see, this interface lead works really well. It costs bugger all to make. You just need an FTDI, one diode, bit of wire, and a 3.5mm stereo connector. And if you like, you can make it socketable with a header socket there. It's always handy keeping a few Schottky diodes in the parts bin, and your local Ultronics carries the BAT85, whilst JCar has the BAT46. This has similar VF specs to the BAT85. If you go to my website, vk4ghz.com, you will see an article there on this project. You can download a PDF which describes how to build this. It's got photos and the schematic there. There's just one thing left to do. Thanks for watching. You'll see me next time. Cheers.
Boo! Boo! That was the worst thing I ever heard. It was terrible. Horrendous. Well, it wasn't that bad. Oh, yeah? Well, there were parts of it I liked. Yeah, I liked a lot of it. Yeah, it was good. It was great. It's wonderful. Oh, bravo. More.
Now can I say it?
Yep.
Go away!
Scram!
Get out of here!
Get out of here! Skedaddle! Go away!
Ham's gray!
Well, come on.
All right.